So Algebra 2, here's my 10 minutes of video. Turn to page 6 in your notes, and I want you to follow along to the best of your ability. Okay, so page 6, we're going to start with the like radicals. So example 4. I can get this to work. Okay, so the best example, or the best way I can get you to think about this, is to think about using variables instead of square roots. So as long as those square roots are the same, you can add or subtract, just like variables. If those were variables, x, so 1 in front, right? 1x plus 7x is equal to 8x. Well, it's the same idea here. 1 plus 7, those are the components you add together, equals 8, and then you have the fourth root of 10 still. So you're just going to add your coefficient terms. The key is that the green pieces have to be identical. The green pieces have to be the same, and they don't change. It stays the fourth root of 10 in the answer as well. All right, same thing down here. 2 plus 10, I can add those pieces because the 8 to the 1/5, or the fifth root of 8, is the same. So it ends up being just 12, parentheses 8 to the 1/5 power. I know that glare is pretty bad, but hopefully you can kind of see it there. So you just add the coefficients. Okay, moving on. Letter C, you'll notice that they're not the same. So the 54 and the 2, the cubed root of 54 and the cubed root of 2 are not the same, so you can't add or subtract unless they are the same. So your job is to make this, the cubed root of 54, hopefully somehow match the cubed root of 2. So if you go to your green sheet, I've got my perfect cubes kind of highlighted in yellow there. So you want to find a cubed root that would come out of 54. So 8 won't work, 27 will work. So we're going to use 27. 27 has a cubed root of 3. 27 has a cubed root of 3. So this is what we did yesterday, very similar to example 3, letter A, repeating the exact same idea right there. So 54 is going to turn into the cubed root of 27 times 2 minus, and I'm just going to rewrite this, the cubed root of 2. All right, well, the cubed root of 27 is 3. So it ends up being 3 cubed root of 2 minus the cubed root of 2. So I can subtract the coefficients. So I'm going to go ahead and subtract. I'm videoing. You are welcome to come in, but I'm just going to talk through it if that's okay. Okay, so you're going to subtract the coefficients. But you can only subtract the coefficients as long as the square root values are the same. Or not square root, but the cubed root values are the same. So 3 minus 1 is 2, cubed root 2. So again, the whole idea of this concept is that you have matching or identical root values. And if you don't, you need to create that to be able to add or subtract. All right, moving on. Let's go to example 5, please. So same page, looking down at example 5, this is kind of the last set to this section 6.2. So we'll work on practice questions after we get these down. All right, so example 5, letter A. You're taking cubed root now with variables, so the difference is that you have variables too. You can split up the variables and the numbers. They don't have to stay together. So it could look something like this, the cubed root of 64 times the cubed root of y to the 6th. Remember, we also talked about how it could be 64 to the 1/3 power and y to the 6th to the 1/3 power. Can you see that? Okay, so the whole point is to try to get each piece individually broken down. So if we look at the cubed roots, you want to see where 64 lies, if it happens to have a cubed root, which would be nice. and it does. So the cubed root of 64 is 4. So I can go ahead and make that be 4. And then like we've talked about before, when you have exponents separated by parentheses, you multiply those. So you multiply 6 times 1/3. And 1/3 as a fraction just means you divide. Anytime you have a fraction, that denominator is what you divide by. So 6 divided by 3. So you're, in essence, when you have a root out here, that's the number you divide by. So it is 4 times y to the 2nd power. All right, so dividing is key. Let's take a look at one more. So 27 to the cubed root, you're just taking this through everything. And then you're dividing each of these exponents by 3. So 27, does it have a cube root? Lucky, again, it does. So it's a cubed root, so 3p cubed to the 4th. And you just divide. All right. Thanks. All right, 2 minutes left. I've got 2 minutes. I'm going to do 2 more examples, and then that should cover our 10 minutes. We'll see where that takes us. All right, let's take a look at letter C. And then I'll do letter A here and B. And that should be enough. All right, so I'm now on page 6. Now on page 6, remember this means divide when it's ever a root like that. So you're just going to divide. So m to the 4th divided by 4 is 1 over n to the 2nd. Pretty simple. Not too bad. Skip down to A. All right, obviously when you look at division here, you have 8 divided by 5, 14 divided by 5, and 5 divided by 5. The only one that works is the 5. So you have to divide, you have to split apart the other ones to find something that will divide by 5. For example, you're going to change it so that it's, just leave the 4, because the 4 doesn't have any factors inside of it with a 5th root. We're going to go a to the 5th times a to the 3rd. So I'm taking this a to the 8th and breaking it into the 2 pieces, a to the 5th, a to the 3rd. And the point of that is so that I can take the 5th root of a to the 5th. That glare is horrible. My apologies for that. All right, keep going. So it's going to be b to the 10th times b to the 4th, and c to the 5th is just fine. So I take this b to the 14th, and I broke it into the 10th and the 4th, because you want the biggest value that you can take out that's divisible by 4, or 5, divisible by 5. So then this becomes the pieces, let me highlight the pieces that I'll fix. I'm going to take out the pieces that actually have roots. So the ones that I circled, a to the 5th divided by 5 is a, b to the 10th divided by 5 is 2, and c to the 5th divided by 5 is 1. So all of those come outside the square, or the 5th root symbol, leaving me 4, a to the 3rd, b to the 4th. Okay, and then the last one, I think I'll have to do, oh, do I still have time? Oh, I'm rocking it, 8:40, we're good. All right, so let's do one more. So I want to come up with a way to make y to the 8th completely divisible by 3, and 8 is not doing that. So I'm going to go ahead and multiply it by y, so that I have the cube root of x, y on top, and y to the 9th on the bottom. So you end up with the cube root of x to the y, or x times y on top, and then you divide 9 divided by 3 to be y to the 3rd. Okay, so that covers everything in that section. If your notes are complete, you get points for watching.